Hello class, today we are covering 7.1 integration by parts. This is Math 1440, and this is going to be a new technique for integration. So in Math 1430 we learned a bunch of techniques, but the problem we're going to look at today cannot be solved by the techniques that we learned in Math 1430. We're going to need integration by parts to answer the following problem coming up. Okay, so what is integration by parts? Well, it allows you to rewrite the integral as in the form, the integral of u dv, where u is easy to differentiate and dv is easy to integrate. So the word differentiate means you can find a derivative. Okay, and here's the formula that we're going to use, and this is proven in your book. You do not have to know the proof, but here it is. You can write your given integral when you think you need integration by parts as the integral of u dv. So you write it in this form. Think of your first factor as u and your second factor as dv. Because if you can write an integral in the form u dv, then it can be proven that it's equal to u times v minus the integral of v du. And the whole point of this is that this resulting integral should be easier than the original. Therefore, you're able to do the integral. Once in a while, not too often, you're going to find that this integral is still hard. So you may have to do integration by parts again. Or maybe just a u substitution. Who knows? It depends on the personality of the problem. Okay, so with that being said, let's take a look at our first and last example for today. We want to evaluate this integral, x squared times e to the x dx. This is a product, and there is no product rule for integration. And like I said, we don't know how to do this in Math 1430. So we're going to do this by integration by parts. So what you want to do is let u equal one of the factors so that it's easy to differentiate, and then let dv be everything else so that it's easy to integrate. All right, so here we go for a solution. Note there is no product rule for integration, or a u substitution will not work. So this leads us to think about integration by parts. So what I did was I chose u to be x squared and then dv e to the x dx, because the derivative of u is easy enough and the integral of dv is easy enough. So, and by the way, it's not obvious, you might be tempted to say let u equal e to the x, because that's an easy derivative, and let dv be x squared dx, because that would be easy to integrate. So sometimes you just have to guess. But as a rule of thumb, if e to the x or e to the 2x, whatever, is one of the factors, let dv equal the e to the power. Usually that's going to work. And the way you can kind of remember that is e rhymes with dv. Okay, so once you get your u and dv, then you want to complete the toolbox, as it's called. So once you know u, let's find du. So du is going to be the derivative of the x squared, which is 2x dx. You could also think of saying, let's find the derivative of u with respect to x. So if you think of it like that, then we would have du dx is 2x. And then solve for du by multiplying each side by dx. So either way, you're going to get du is 2x dx. We want du. Why do we want du? Because look at this formula. It involves a du. Okay, and now if I chose u as x squared, then dv is going to be everything else. So dv is e to the x dx. Don't forget to write that dx. And we can integrate each side. The integral of dv is v. The integral of e to the x dx is just e to the x. You don't have to write plus c because this is just the toolbox, as it's called, toolbox. This is the toolbox. So now with the completion of my toolbox, we can now proceed with the problem, because this original problem here, isn't this of the form the integral of u dv? By the way, I chose u and dv. Yes. And what is the integral of u dv? It's uv minus the integral of v du. So let's focus on this right-hand side. So here we go for the problem. So I rewrote our question. We want to evaluate the integral of x squared times e to the x dx. And then I know that's of the form, the integral of u dv. So what's the integral of u dv? It's uv. So for us, x squared e to the x, that's what uv is, minus the integral of v du. So there it is, minus the integral of v du. Let's simplify this integral before I integrate. So to the next step, we have this is the same thing as x squared e to the x, and then I pulled out the 2 on the other side of the integral. So it's 2 times the integral of e to the x times x dx. But this integral looks brutal. It's another product, and there is no product rule for integration. So this is one of the rare times where we're going to have to roll up our sleeves and do this integral again by integration by parts, as it turned out. So usually you do integration by parts if you have factors that are unrelated, like one factor involving x's and the other factor involving e or ln. That's typically when you think about integration by parts. So as not to interrupt the flow of this problem, I'm going to go and concentrate just on this integral, get the answer, and then go back to continue on with this problem. So let's go to secret thoughts, as I like to call it, ST, secret thoughts. Let us just do this chunk of the problem. What is the integral of e to the x times x dx? So here again, let's do integration by parts. Let's let u equal x, and then dv is everything else, which is e to the x dx. Remember, dv and e rhyme, so they go together. Okay, then you want to complete the toolbox. If u is x, du is dx. Take the integral of each side, and you're going to get v is equal to e to the x. Don't worry about the plus c, because this is just the toolbox. And now this is going to work. So now we're going to write, let's rewrite what we're looking for in secret thoughts. What is the integral of e to the x dx? I wrote it right here. The integral of e to the x dx equals, because this is of the form, the integral of u dv, I know the answer is going to be u v minus the integral of v du. So let's do that. So the integral of this u dv is uv, that's where the x e to the x comes from, minus the integral of v du. V du is e to the x dx. And that is an integral we feel comfortable with. So let's just solve that integral. So my final answer for this one chunk of the problem is going to be rewriting x e to the x minus, and now the integral of e to the x dx is e to the x plus c. So now with this answer, we're going to plug it in for back to here again. So this we figured out in secret thoughts. You don't have to write secret thoughts. I just went to the side of the paper to just work on this one little chunk of the problem. So let's continue now with this original problem that we're doing. This is our original problem. We ran into a stumbling block here, so I went to secret thoughts, got this answer as this right here. So now let's return to the scene of the crime. So our answer to the original problem is going to equal, rewrite this first part, x squared e to the x minus 2 times, and then this integral gets replaced with this expression. So that's the expression. Put the plus c at the end. You don't put it inside the parentheses, because 2 times c is just another c. So you might as well just write plus c at the end. Okay, and I would accept this answer as a final answer, or you could distribute the minus 2, which is what I did next. X squared e to the x minus 2x e to the x plus 2 e to the x. Notice I wrote plus because what's a minus times a minus? And then you write the plus c. Now on WebAssign, who knows? You know, they might want you to take out a GCF, greatest common factor. So isn't e to the x common to all of these terms here? So that's what I did next, just to be safe. Pull out e to the x, the GCF, and then you're going to be left with x squared for the first term, minus 2x for the second term, plus 2 for the third term. Close the parentheses, and then plus c. And we're done. So there's the block indicating done. That block is optional. All right, so hope this worked out for everyone. So before you do the 7.1 homework on WebAssign, you should always you should always look at the notes from Learn under announcements. Look at the notes for 7.1. They're already up there. Look at this video. And look at the WebAssign video for 7.1. That way you'll be totally prepared to do the homework. Okay, good night, everyone.